Hello everybody. Gravitation mainly is based on these concepts. One, the concept of geocentric theory, heliocentric theory. What are their drawbacks? Geocentric theory, according to that one, Earth is at the center and the planets are revolving around the Earth in circular orbits, which was taken wrong at a later stage. Heliocentric theory says Sun is at the center and all the other planets are revolving around the Sun in circular orbits. When we talk about these two, there is a drawback in this. The drawback is this: seasonal changes on the Earth or any other planet could not be explained by taking this geocentric theory or heliocentric theory. Thereby, taking the positive points and negative points of these two theories, Kepler has given three important statements, which of course we call them as Kepler's laws of planetary motion. According to this Kepler's laws, the orbit is not circular and it is going to be elliptical. Second one, the angular momentum of the planet in an orbit is always going to be constant. Third one, square of the time period of the planet is directly proportional to cube of mean radius vector, that is mean distance from the planet to the Sun. So all these points of course we have to remember before going to this chapter. Exactly like that, what is the formula for capital G and small g? What is the relation between these two? Gm by r plus h whole square, like we people used to take. And what is the formula for gravitational force between two different bodies having masses m1 and m2? G m1 m2 by r square. All these formulae are supposed to be remembered before going or entering into this particular chapter as such. In addition to this one, what is meant by escape velocity, orbital velocity, what is gravitational potential energy, and other applications of these things, in fact, we people are taking up in this particular chapter. As you are all already familiar with all these formulae, let us now take up some of the applications of this particular chapter as such. Let us see the very first question what has been appearing here. Two spheres of masses m and capital M are situated in air and the gravitational force between them is F. The space around the masses is now filled with a liquid of specific gravity 3. The gravitational force between them will now be how much? If you look at this particular formula for the force of gravity between two different bodies, which is called otherwise as gravitational force between two masses of m1 and m2 separated by a distance r, there is a constant of proportionality which is taken as capital G. Capital G of course is said to be universal gravitational constant. That is actually the name given to it. The word itself indicates universally it is going to be constant. It is independent of the material medium that is there in between the bodies. When we look at this particular problem, initially the force between the bodies is given as F. Now the space between the bodies is totally filled with a liquid of specific gravity 3. Just now I have given you this capital G is independent of the medium between the bodies. There will never be any sort of a change in the force of gravity between the bodies now. That means since G is independent of the medium, it does not vary with the specific gravity of that liquid what has been taken inside in between the bodies. Therefore, your answer will again be F itself. That is the third option which is going to be correct there. That is the concept. Right. Now let us take the second number there. If you look at the problem, the gravitational force of attraction between two bodies is 6.67 into 10 power minus 7 Newton, when the distance between their centers is 10 meter. If the mass of the first body is 800 kg, then the mass of the second body is how much? It is a direct application of this particular force what has been taken as the gravitational force. F is equal to G into m1 m2 by r square. That is the formula in fact we know. What is the force that has been mentioned in the problem? You look at 6.67 into 10 to the power minus 7. But all should remember the value of capital G, 6.67 into 10 to the power minus 11 Newton meter square per kg square. That is actually the value of capital G. This usually will not be given at Eamcet examination. You have to remember that value and do it. Now, if you take the masses, one of the masses is given as 800. The second mass is to be calculated. I write that one as M2. What is the distance of separation? That is given 10 meter here. 10 square now becomes 100. So, if you just cut these two zeros, 6.67 on both sides gets cancelled. 10 to the power minus 7 cancels over here minus 4 times. So, what now is remaining, you check it, M2 is equal to 1 by 10 to the power minus 4. That of course you people can understand directly, this 7, 11 and of course 8 also is there, 8 M2 is equal to 1 by 10 power minus 4. Then what we can write, M2 is equal to 10 to the power 4 by 8. You can directly understand what is this value equals to 1250. What for you can think of, 10 power 4 can be written 100 into 100 by 8. This 8 of course 4 gets cancelled twice and there of course 25 times. So totally 1250 kg will now be the second mass what he is talking about. So this is a direct application of this Newton's law of gravitation as such. Now let us check the next number here please. Second option is the correct option for this obviously. Now two spherical bodies of masses capital M and 5m having radii capital R and 2r respectively are released in free space with initial separation between their centers as 12r. If they attract each other due to gravitational force only, then the distance covered by the smaller sphere just before collision is. This particular question has got a small link up with the topic called collisions. I just want to tell you one point. Suppose two bodies, due to their mutual attraction, they are just moving towards each other. When they are colliding at some point, say P, you should understand that this is the point which is going to be the center of mass of the entire system. So they will definitely be colliding at the point called center of mass, that is understanding here. So what you need to understand here is m is the first mass, 5m is going to be the second mass, center to center distance is given 12r, that is the concept. Now of course 12r is okay, but what is its radius? That is given capital R. The radius of the second one is given 2r. Then you can understand from the surface of this body to surface of this body, the total distance now left is going to be 9r. Because you can understand 2r plus r now becomes a 3r. 12r minus 3r now will be 9r as such. So if at all they are coming closer, from surface to surface, they have to travel a distance equals to 9r as such. That is the point. Now, where will they collide? I have already told you. They collide at the center of mass. So, what will be the distance to the center of mass from the first body? Already we people have discussed this formula in center of mass chapter. It is m2 by m1 plus m2 into r, r being the total separation between those two bodies as such. So, what you should understand is m2 is now 5m. You can get that idea. m1 plus m2 now will be 6m into what is this r now? It is 9r, m getting cancelled, twice 3 and thrice 3. So, it is 15r by 2 which now becomes 7.5r. What is the distance travelled by the smaller sphere? That is the question asked. So look at that one. The first option is exactly tallying with this number. 7.5 r will now be the distance travelled by the smaller sphere before these two bodies are colliding with one another. That is the concept. Now check the next question please. That is question number 4. Three identical particles, each of mass small m, are kept at the vertices of an equilateral triangle of side A. the gravitational force of attraction on any one of the particles would be. This kind of a problem is a very commonly asked model question at different entrance examinations, including Eamcet as such. Equilateral triangle he is talking about, the sides are equal to A each. That is what has been mentioned. And how many masses are placed over here? At each corner, one body of mass m that is being placed like. Now the question is gravitational force of attraction on any one of the particles, that is the question. If you consider, for example, this is the body. This body is now going to be influenced by two more bodies. That means the force of attraction between these two, if I take that one as F1, the force of attraction between these two, if I take that one as F2, since the masses are equal and the distances are equal, F1 and F2 are going to be equal. Then what is this for value of F1 or F2 here? That is equal to F only. But how to write this formula? G m1 m2 by r square in this case will be a square. Because the distance of separation either between these two bodies or between these two bodies, it is going to be given as A itself. Now coming to the next one, since it is equilateral triangle by nature, the angle between them will be 60 degrees. So I should now take the angle 60 and I have to apply the concept of parallelogram law of vectors to get the resultant force over there acting on the body. So what will be the resultant over here now? It is simply f root 3. When theta is 60 degrees and f1 and f2 are equal, what will be the resultant force by formula? F root 3. Then what will be your answer now? Root 3 times gm square by a square. This is the answer that is going to be tallied with exactly the second option there given, that is root 3 times gm square by a square. That is the correct option for this one. Now look at the next question, that is problem number 5. The gravitational force between two identical objects at a separation of 1 meter is 0.0667 milligram weight. The masses of the objects are, of course, what are the values of their masses is the question. Capital G, of course, is given in this question, 6.67 into 10 power minus 11 Newton meter square per kg square, and G is 10 meter per second square. These are the values given to us. Now look at what are the values given and what is to be calculated from that. According to the version given, the force of gravity between two identical bodies, that's given 0.0667 milligram weight. 0.0667 mg weight. What is milligram to gram? 10 power minus 3. Gram to kg, 10 power minus 3. So totally this will be 0.0667 into 10 to the power minus 6 kg weight. That is the conversion first and foremost. Now of course if we eliminate this point, 667 into 10 power minus 4 we can write 10 power minus 4 and 10 power minus 6 totally now become 10 power minus 10. What? Kg weight. But we know pretty well each kg weight is equal to 10 Newton, that is G Newton. Therefore, what will be the force here now? 667 into 10 to the power minus 10 into 10, that is 10 power minus 9 Newton. This is the given force over here. So writing the formula here, G m1 m2, that means m square by r square. I just want the value of m square here. That is fr square by g here. What is f now? 667 into 10 to the power minus 9 into what is the separation distance that is mentioned over there? It is 1 meter. 1 meter square of course will be 1 only. What is capital G? 6.67 into 10 to the power minus 11. You can cut this one minus 2 times first of all. Now if you look at this one, this now becomes 667, this is 667 into 10 power minus 4. So 667, of course if you cut this one over here, 100 times it goes. So 10 to the power 4 you get as m square. Then what will be m now? it is 10 square. 10 square will be how much now? 100 kg. Since the masses are equal, first mass as well as second mass, both are 100 kilogram each. That means the second option is correct option, which is tallying over here. This is the way of calculating the masses here. Now look at the next problem, that is problem number 6. If acceleration due to gravity on earth is 9.8 meter per second square, its value at a height of 6400 kilometer is how much? In fact, all of us we know radius of earth is also 6400 kilometer we people used to take up. And of course, altitude effect, according to that, G at an altitude h by g is equal to r square by r plus h whole square. This is actually the formula what has been derived by all of you. So if you look at this value, what is gh the question now? It is r square by r plus h whole square. But of course you know very well r is 6400 kilometer. H also is given in the problem 6400 kilometer. Therefore this can be written r plus r whole square. How much it is? 2r square whole square means 4r square. This multiplied by g. So r square gets cancelled. What is now left over? G by 4. G value is already given 9.8. By 4, how much will be the value now? 2.45, right, meter per second square. This is the acceleration due to gravity at an altitude which is equal to the radius of the earth as such. So third option is the correct option for this particular question as such. Let us now check over the next number, please. That is problem number 7. A simple question which is theoretical by nature. If a person of mass m moves from the equator to the north pole of the earth, then his weight, what happens to his weight? Similarly, they can even ask what happens to his mass also. Suppose if you take up earth as a spherical body. All of us in fact we know earth is not perfectly spherical. It is having flattened poles and bulged out equator like this. Equator has been bulged out, due to which equatorial radius is definitely greater than polar radius for the earth. So automatically what you observe here is the acceleration due to gravity at poles will be greater than acceleration due to gravity at the equator. When the person is moving from equator towards the pole, then automatically g increases over here. When g increases, what happens to the weight of the personality? That also is going to be increased. That means what is the correct option there? It is the first option, which of course increases is the concept there. But remember carefully, by any chance if they ask you in the same question, what happens to the mass of the person? Mass is the one which is not going to be changed. It does not depend on g at all. Therefore, mass is going to be unaffected. Remember that concept also along with this question, please. Now look at that next question, that is 8th question as such. Acceleration due to gravity on the surface of earth is 9.8 meter per second square. Its value at a depth of 320, in fact one more 0 is missing there, 3200 kilometer. That is the correct one for these options. That is radius of earth is 6400 kilometer. That means to what depth we people are going there means half the radius we are going. It is understood. What is the effect of depth on acceleration due to gravity? Gd is equal to g into 1 minus d by r. That is the formula. But all of you just change that value, please. D, the depth that is given, it is supposed to be 3200 kilometer. And what is radius of earth given? 6400 kilometer. Already we know that. Therefore, g at this much of depth is equal to g into 1 minus 3200 by 6400, which now goes twice here. Therefore, 1 minus 1 by 2, that now becomes g by 2 as such. So what is the value of g given? 9.8 by 2. Automatically you will be getting the value as 4.9 meter per second square. One small change is to be made here. 3200 kilometer, that is to be taken up. Then automatically the value of acceleration due to gravity becomes 4.9 meter per second square, which coincides with the third option over here. Now look at the next number, that is problem number 9. the height at which the value of acceleration due to gravity becomes 50% of that at the surface of the earth. Once again, radius of earth is given 6400 kilometer. Now in this particular case, look at carefully. GH by G must be 50%. In other words, you can write the same this way also. GH must be 50% of G. That means what? This goes twice over here. Therefore, GH must be G by 2. That is the very meaning of that particular question. So, you can write GH by G is equal to 1 by 2 according to this calculation, which now is equivalent to R square by R plus H whole square. That is officially the equation what we all know. Now, if you take the root on both sides, R by R plus H will now be 1 by root 2. Then what will be the value? R root 2 is equal to R plus H. That is the concept. Now if you want H value, R into root 2 minus 1. Root 2 being 1.414, every one of us we know that. So 1.414 minus 1 will now be 0.414 into the radius of earth what has been given over here is 6400 kilometer. So if you just simplify this one, the value of height now becomes near around 2650 kilometer. That means 2650 kilometer you will be getting over here, and that value coincides with the very first option in this particular problem as such. So option 1 for that question number 9. Look at the next question please, that is question number 10. The angular velocity with which Earth should rotate such that the acceleration due to gravity at 60 degrees latitude becomes 0. That is the concept. Of course, we all know what is the influence of latitude on the value of G. G at a latitude phi is equal to G minus R omega square cos square phi. That is the formula officially we all should remember. Now in this particular case, phi is given 60 degrees and at the same time cos square phi now becomes 1/4. So it is now G minus R omega square by 4. But that should be equal to how much? Given it is 0. That means it should rotate so such that the acceleration due to gravity at 60 degrees latitude should become 0. That means you make this one equals to 0. R omega square by 4 is equal to G. Now automatically omega square can be written 4G by R. Therefrom omega can be written as root of 4G by R. Of course, if you take the value roughly as G as 10 by R is 6400 kilometer, that is 64 into 10 to the power 5 meter you can write. Now if you simplify this total lot, this of course goes 16 times, this goes 4 times, you will be now getting 1 by 4 into 10 square. That of course 1 by 4 is 0.25 into 10 power minus 2 radian per second you are getting. But of course the same answer can even be rewritten as 2.5 into 10 power minus 3 radian per second. This must be the angular velocity of that particular earth for having the latitude 60 degrees at that particular latitude, G value becomes 0. So which option is tallying here? The very first option that's going to be tallied. That is the concept we have to take up. Right? Now look at the next number, that is question number 11. The acceleration due to gravity on a planet is 1.96 meter per second square. If it is safe to jump from a height of 3 meter on the earth, the corresponding safe height on the planet. An excellent concept in fact. What is safe height actually? Where from actually one body is to be dropped so that the body will not have any sort of a damage for it. The point is this, you can understand that root of 2gh, that is actually the velocity. Out of that, G and 2h must be constant. That means every body, whatever is reaching the planet or the ground on the earth, whatever it is, that g into h must be constant. This is the condition for safe height. So automatically you can understand h is inversely proportional to g. Therefore, h1 by h2 is equal to g2 by g1. That is the concept. And what is the value of h1 that is given on earth, please? It is given 3 meter. Now h2 is to be calculated. And what is g1 that is given? Of course, we all know this as 9.8. g2 value is given 1.96 meter per second square as such. So automatically what happens in this case is this goes exactly 5 times. Then what will be h2 here, please? 15 meter. That means even if you drop the body at 15 meter height on that planet also, the body gains the same velocity as it is gaining on the surface of the earth. That is the concept. So which option is correct for this one? Fourth option is correct over here, 15 meter. That is question number 11. Now look at the next number, problem number 12, please. Two bodies of masses 2 kilogram and 8 kilogram are separated by a distance of 9 meter. The point where the resultant gravitational field intensity is 0 is at a distance of what exactly the distance we want. But remember once again, 2 kilogram and 8 kilogram it is supposed to be, not 8 gram as such. Look at that one once again. One body is here 2 kg. Other body is here 8 kilogram. These two are the masses he is talking. What is the separation distance given? 9 meter. Now the question is, where will the gravitational field intensity 0? What is gravitational field intensity? In fact, we all know it is the force experienced by unit mass placed at that point of consideration. So if you take, for example, this is the point P where the gravitational field intensity is 0. Then what can we understand here? If I imagine a unit mass is placed there, then the force of attraction between these two bodies and force of attraction between these two bodies are supposed to be equal and opposite. That means the effective force experienced by this unit mass is supposed to be 0. That is the concept. So come on, take what is the force between these two first? G m1 m2 by r square. I take that r as x over here. Now is equal to G m1 m2 by r square. m1 is 8, m2 is m. r square, this is now 9 minus x the distance. I can write 9 minus x whole square. M gets cancelled and G gets cancelled. 2 cancels 4 times. Then what can we write? 9 minus x by x is equal to 2. So 3x will now be equal to 9 because this is 2x plus x. That now becomes, x becomes 3 meter. X becomes 3 meter is okay. But where from it is 3 meter? From 2 kg mass it is 3 meter. But see the options please. He has not given 3 meter from 2 kg mass like. He is giving from 8 kg mass. Total value is 9 meter means 9 minus 3 will be how much? 6 meter from 8 kg mass. The third option is going to be exact and correct answer in this particular case please. So for the 12th question, the correct option is the third one. Now look at the next question please. Problem number 13. A planet moves around the sun at a given point P. It is closest from the sun at a distance d1 and has a speed v1. At another point Q, when it is farthest from the sun at a distance d2, its speed will be. In fact, we all know according to the second law of Kepler, angular momentum of the planet revolving around the sun is supposed to be constant there. Angular momentum means we all know that one mvr must be constant. Out of that one, m being constant, v into r must be constant. That is the concept we have to remember there. Now what is the velocity over here given at P? It is given as v1. And what is r that is given? R is nothing other than the distance given as d1. And of course, what is the second velocity we just want? I write that one as v2 and the distance therefrom that is given is now d2. What will be v2 the question? It can now be taken v1 d1 by d2 over here. V1 D1 by D2. If you look at the third option, that is exactly tallied with this. The moment V into R is constant, you can even write this one, V1 R1 is equal to V2 R2. This is the formula what I just have applied over here to calculate the velocity of that planet at another point, say Q, in this particular question. That is 13. Right, the correct option is 3 for that. Now look at the next question please, problem number 14. For a satellite, escape velocity is 11 km per second. If the satellite is launched at an angle of 60 degrees with the vertical, then escape velocity will be. In fact, the same question, same model question has been asked at Eamcet level once. He has given the value of angle as 45 degrees, that's all is the only variation. So you people can all understand escape velocity is under root 2 gm by r plus h. That is one way of writing the formula. The other method of writing the same formula is this. It is under root 2 gm by r. This can be taken when h is negligibly small comparing to the value of r. Whatever be the equation you talk about, escape velocity is independent of few aspects. Every one of you should remember that one carefully. Escape velocity is independent of the shape of the body, size of the body, nature of the body, mass of the body, above all the angle of projection of the body. At what angle the body is being projected and all, we don't have any angle terminology here at all. Therefore, escape velocity will not be varied depending on the angle of projection. Therefore, what will be the escape velocity now again? Again it will be 11 km per second only. So, what is to be understood here? The fourth option is the correct option, and one should remember that escape velocity is independent of nature of the body, shape of the body, size of the body, mass of the body, and above all angle of projection of the body. These are the points we have to look into. So, fourth option is correct for this 14th question. Now, look at the next question, that is problem number 15. Imagine a light planet revolving around a very massive star in a circular orbit of radius capital R with a period capital T. If the gravitational force of attraction between the planet and the star is proportional to r to the power minus 5 by 2, then t square is proportional to what? This is a bit of manipulated question like. In fact, we all know very well g m1 m2 by r square. That now is going to be mr omega square, the formula. If I take this being the centripetal force acting on the planet, that will be the centrifugal force acting on the same planet for the planet to move in the same orbit without any problem. Now, in this particular case, what is given now? R square, of course, it has been given that r to the power minus 5 by 2. Minus 5 by 2 means 1 by, I should write r power 5 by 2 here. But in place of omega square, what I can write? mr into 4 pi square by t square I can write here. Now, if you write that one, gmm by r to the power 5 by 2. Now, cross multiply this one. This m anyhow gets cancelled. 4 pi square constant, g constant, m constant. Only r and t are variables. So, t square is proportional to r power 5 by 2 into r. That will now be how much? R power 7 by 2. So, t square is proportional to what now? It is r to the power 7 by 2. What is the correct option here? The second option is going to be given as r power 7 by 2. So, that is the correct option for this question number 15 as such. Now, look at the next number, that is problem number 16. A satellite is moving very close to a planet of density rho it is. The time period of the satellite is how much? Time period of the satellite means once again one has to go for centripetal and centrifugal forces acting on it. Gmm by r square is equal to m r omega square. Same formula once again I am using there. This now can be rewritten as mr into 4 pi square by t square like I can write. That is the concept. Now, if you look at this one, m anyhow gets cancelled. This r, of course, I take capital R there. Now look at carefully. This G by R square I write as it is. Capital M now can be taken 4 by 3 pi R cube into rho. Volume into density is going to be mass of the planet. That is equal to what? Here what is left over? R into 4 pi square by T square. That is the formula. Now look at carefully. R square cancels R times. This R and this R they get cancelled. This 4 and this 4 they get cancelled. This pi and this pi they get cancelled. Now what is left over towards your left, you see? G rho by 3, that is left towards your left. Now what is left on the other side? Pi by T square is left on the other side. So T square will now be how much? 3 pi by G rho. That is the concept. Now what will be the value of time period is the question. Root of 3 pi by G rho. This is the corresponding formula. That of course if you look at the very first option is tallied with the same answer. So first option is correct for this question number 16. Let us now check the next problem please. That is question number 7. A satellite revolves around the earth in an elliptical orbit. Then what happens? In fact, you all know according to the concept of second law of Kepler, when we consider an elliptical orbit, if this is the position of the sun, then you can understand when the satellite is very close to it, the planet is very close to the sun, its velocity will be maximum. When it is very far from this one, velocity will be minimum. That is the basic concept we people have to take up. So its speed is the question. Look at the third option now. Its speed is greatest when it is closest to the earth. If I take this one is sun with respect to a planet, this is the concept. Suppose if I imagine earth is here and planet of course is revolving around the earth in an elliptical orbit, for example like this, then also the concept will be the same. When it is very close, the velocity or the speed is going to be maximum. So which option that is being tallied directly? Third option is being tallied, greatest when it is closest to the earth. That is the concept you have to take up. So option is 3 for 17th question. Now look at the next number, that is problem number 18. Two planets have radii r1 and r2 and density is ρ1 and ρ2 respectively. The ratio of accelerations due to gravity at their surfaces will now be how much? One point you people should remember. In fact, small g is equal to gm by r square formula, every one of us we know. Now this can be rewritten as g by r square into 4 by 3 pi r cube into rho. Mass can be written as volume into density. Out of that r square cancels in this one r times. Then what is left over you see now? 4 by 3 pi g r rho. That means you can understand g is directly proportional to r and directly proportional to rho. So what you people can understand, two planets have radii r1 and r2, density is ρ1 and ρ2. Then what can we write? g1 by g2, acceleration due to gravity on the first planet by acceleration due to gravity on the second planet is equal to r1 by r2 into ρ1 by ρ2. This rho in fact is called generally the average density. That is actually the concept you have to take. So which option once again is being tallied there? Exactly the same value is given as option number 1. So first option is going to be correct for this question number 18 as such. Look at the next number, that is problem number 19. The distances of Neptune and Saturn from the sun are 10 power 13 and 10 power 12 meter respectively. Assuming that they move in circular orbits, their time periods are in the ratio. According to third law of Kepler, square of the time period of a planet is directly proportional to cube of the mean distance to that planet from the sun. T square is proportional to r cube is the corresponding formula for us. Now in this particular case you can write T1 by T2 must now be equal to root of r1 cube by r2 cube. That is the corresponding formula for us. If you take r1 cube by r2 cube, like what are the values given of r1 and r2? 10 power 13 by 10 power 12 under root you can take up. That too, of course, 10 power 13 what? Whole cube. That means a whole cube I can write this way. Now 10 power 12 cancels here 10 times. So what is now left over? Root 10 cube you people are having. This now can be written as 10 square into 10. After all, we can understand root 10 square is 10. So 10 root 10 will now be the ratio of the time periods of both the planets as such. So what is the correct option there? It is 10 root 10. That means the second option that is going to be correct. But one thing one should remember here, t square by r cube is constant, is valid for every planet revolving around the sun. That's one aspect. Secondly, same equation even you can apply for electrons which are revolving around the nucleus of an atom also. So even there also it is applicable, and this formula is important in this chapter as well as in chemistry, like in electrons, like when we are talking about the rotation or revolution of electron around the nucleus like. So that is the question number 19. Now let us take the next number, question number 20 here. If r is the radius of Earth, then the height above the surface of Earth where acceleration due to gravity becomes half its value at the surface of the Earth. Once again, already we have discussed the same model earlier almost. You know very well GH by G must now be equal to half. That means what? GH is equal to G by 2 is the relation what has been mentioned there. So GH by G must be equal to half means, according to the formula, R square by R plus H whole square. That is the corresponding equation for GH by G. Now here he is not mentioning what is R, what is H and other things like. Therefore H value to be written in terms of R. Now come on, just take root on both sides please. R by R plus H can be written as 1 by root 2. Now cross multiply this one. R plus H is equal to root 2 times R. That is the concept. Now if you bring this R that side, H now becomes root 2 times R minus R. Taking R common, root 2 minus 1. That is actually the equation. So H is equal to R into root 2 minus 1. What is going to be the correct option here? You look at once again. The fourth option is going to be the correct option there. That is root 2 minus 1 times the radius of the Earth. Suppose if they want the value of H directly, then okay, you can write R as 6400 kilometer and root 2 as 1.414, and thereby you can simplify the total value for H as such. That is question number 20. Right, the option is 4 for that. Look at the next question over here. That is question number 21. Two satellites A and B go round a planet P in circular orbits having radii 4r and r respectively. If the speed of A is 3v, then the speed of B will be how much? That is the concept. In fact, when people used to take up the concept like this, right? The concept is this, 4r and r, these two are the radii of the orbits. If the speed of A is 3v, then the speed of B will now be how much? That is the concept. So when you talk about a planet which is just revolving, general equation is what? Gmm by r square must now be equal to the value of mr omega square, that is 4 pi square by t square. That is the concept actually. In other words, you can write the same mr omega square like this also. That is mv square by r also you can write. Now what is the concept here? You can directly understand V and R. This the R, if you take up, this R gets cancelled. So if you cut M on both sides, capital M is constant, G is constant. Therefore, you can say that V square is proportional to 1 by R like. So automatically what can we write now? V square times R is going to be constant. That is the equation you people have to apply. when you are just applying that concept here, what will be the value of r there? So naturally, when you take the same velocity as mv square by r, where v is going to be the velocity, gmm by r square, out of that one r gets cancelled and all. One is of having one velocity of the first one is 3v given, then automatically the second one is having 4r the radius. That means it will be root 4. How many times it will now be? 2 times. So 2 times this 3, which now becomes 6v, the value over here. That means the velocity of this particular second planet depends on the radius there. Radius being 4r, take root 4. Root 4 will now be 2. 2 times 3, that now becomes 6v. So the option, correct option in this particular case is the second option, no doubt. But the point here is, when we look at this particular chapter called gravitation, what are all the concepts we have dealt with today? They are all basics, in the sense they are all based on the concepts of gravitational force between the bodies, the basic concepts of escape velocity, and one general concept of orbital velocity, what is a gravitational field or field strength and other things like. But actually speaking, gravitation chapter has got second half like this. You will have to discuss about the gravitational potential energy. About that one we have to look into few models tomorrow, that in the sense in the next class. Likewise, we are having the other concepts of satellites. What exactly are the conditions for the satellites? In the sense what is called geostationary satellite, what exactly are the principles of that or conditions for that one, and other related concepts of satellites are to be taken up. Likewise, gravitational potential is also one of the concepts we people just have to discuss. So all these concepts are very much there for Eamcet 2013. In the syllabus, we people are having all these concepts. In the next class of gravitation, we people are mainly dealing with these aspects over there in the class, please. So as far as gravitation, the first part is concerned, I hope all of you might have understood what we people have discussed and have a good calculation and all to get more and more number of problems whatever you attempt, right? Good luck. Thank you.